Support for But Why comes from Indeed. With Indeed, you can do all of your hiring in one place, even interviewing. Indeed's hiring tools help you cut through the noise to hire faster and smarter. According to Talent Nest, Indeed delivers 4 times more hires than all other job sites combined. If you're hiring, you need Indeed. Get started right now with a $75 sponsored job credit to upgrade your job post at Indeed.com/PRXKids. Indeed.com/PRXKids. Offer valid through September 30th. Terms and conditions apply.
This is But Why, a podcast for curious kids produced by Vermont Public Radio. I'm Jane Lindholm, and today we're putting out a special episode because something neat is happening this week that we wanted to make sure you are aware of. On Thursday, February 18th, a robot called a rover is expected to land on the surface of Mars and begin collecting information scientists hope will help us learn if life ever existed on that planet. The rover is called Perseverance. Perseverance means not giving up, continuing to work toward a difficult goal even when challenges are placed in your way. And it's quite a challenge just to get to Mars. The rover was launched on a rocket from Cape Canaveral in Florida more than 6 months ago by NASA, the U.S. Space Agency. And it has been traveling through space ever since on a path to Mars. And now people all over the world are eager to watch it land on the planet and get to work. By the way, it's not just Perseverance that's going to land on Mars. There's also a helicopter called Ingenuity. Ingenuity means cleverness, creativeness, and resourcefulness all rolled into one word. Ingenuity, the helicopter, is basically a drone. There's no one inside flying it around, just as there are no people on board the rover. But Ingenuity is the first helicopter to ever test fly on another planet. So when NASA reached out to us this week to ask if we'd like to do an interview with one of the scientists helping to lead this mission to Mars, we said yes. And we brought along some of your questions about Mars for him to answer too. Here's who we'll be talking to in this episode.
My name is Mitch Schulte, and I am the program scientist at NASA headquarters for the Mars 2020 mission and the Perseverance rover. It's a very cool job, so I get to send stuff to Mars, which is really fun. We're sending a new rover, which is a copy of the previous rover, but it has all new instruments on it. And I was the person at NASA headquarters who was responsible for running the process to decide which instruments we got to put on the rover.
How cool does that job sound? Now, on Thursday, the rover, which has been flying through space since July 30th of last year, will finally approach and then touch down on Mars. I thought maybe some of the people who work at NASA would be running around doing important and kind of crazy things on Thursday morning to make sure the landing goes well. But Mitch told me, actually, not really.
What will happen is that the rover will make its final approach to Mars and go through the atmosphere and go through the whole process of safely landing the rover on the ground so that we can start doing the great science.
So you don't have to do anything here on Earth? You just sit back and watch?
Well, pretty much, because we've already pre-programmed the rover to do all of that stuff on its own, because trying to do it in real time is not possible because Mars and Earth are so far apart. So a radio signal between Earth and Mars takes 11 minutes and 22 seconds on Thursday to go all the way from Earth to Mars, and then 11 minutes and 22 seconds to come back from Mars to Earth. So we don't have time to do it in real time. The whole process of the rover landing on Mars only takes about 7 minutes. So we can't do anything to the rover in real time to correct anything. So it's all been pre-programmed to do the landing on its own.
You could kind of picture it like trying to have a conversation with someone where your phone lines are delayed and you say something, but then if you had to wait 11 minutes for the person to respond, but you had already said something else, that's just, you couldn't have a conversation like that or tell somebody what to do on the other end of a phone line like that.
That's exactly right. And we've all been experiencing that as we're working from home, doing everything by Zoom. There is that delay that you get, and that really is a problem if something is happening that you need to tell the rover to do. So we make sure that it accounts for all of those things beforehand so that it can do them without asking us and without us having to tell it what to do.
Hi, my name is Aria. I'm 5 years old. I live in Dayton, Ohio. I want to know what the robots are doing on Mars.
Aria says, I want to know what the robots are doing on Mars.
That's a great question. So the robots on Mars are doing a lot of science and doing a lot of exploring. So there are a lot of things that we know about Mars, but there are a whole lot of things that we don't know about Mars. So every time we send a new mission to Mars and a new rover, we send it to a different place to figure out a new part of the planet. And we want to study the geology. We want to learn what happened to that particular area to make it look like it does. And that also tells us a lot about what has happened to the planet through its whole history. So we see on Earth that variety of things have happened on Earth, and we can read that in the rocks. And so we want to do the same thing at Mars to really understand the whole history of the planet. And one of the more interesting things that we're doing this time that we haven't really done before is looking in the rocks and at the surface of Mars to figure out if life had ever started on Mars, if it may have left behind some signs that it was there. It's going to a place that we haven't been before called Jezero Crater. This is a crater that used to hold a lake. 3.5 billion years ago, it was filled with water, and there was a river that ran into the lake. And so as the river ran into the lake, it left some sediment behind in a fan shape, and we call that feature a delta. So we see those in places like the Gulf of Mexico at the mouth of the Mississippi River here on Earth. And so this is a great place for us to find material from a big wide area where the river brought a lot of material that washed into the lake. There was a nice shoreline around the lake, and so, there were plenty of places where if life started, it might have been a nice accommodating place for that life to live. So we're really going to look at a very exciting place for this evidence.
Hi, my name is Taylor. I live in Greenland, New Hampshire. I'm 8 years old. And my question is there any life on Mars?
Hi, my name's Aaliyah, and I'm 5.5 years old, and I live in Castro Valley, and I want to know, did life ever exist on Mars?
Life on Mars, does it exist now, and did it ever?
Well, this is one of the reasons we keep sending all of these robots to Mars, is we really don't know the answer to that yet. We have not found any evidence yet that's definitive that indicates that life exists on Mars or ever existed on Mars. We think that early in Mars's history as a planet would have been a better time for life to exist on Mars, because right now the surface especially is very cold and it's very dry. There's no liquid water at the surface, and as we know, we all have to drink water, and everything, has water in it that's alive here on Earth. And all of those environments where there's water, that's where we find life. But since there isn't any at the surface of Mars right now, it is possible that life may exist on Mars right now, but probably not at or near the surface. If it does, it probably lives deep underground, where there's a potential for there to be liquid water. But we see that early in Mars's past, there's evidence that there were rivers running across the surface and lakes and all that kind of thing. And so maybe early in Mars's history, life might have been there. And so one of the goals of this mission is to look in those rocks from a really long time ago to see if life might have left behind some evidence of itself.
These signs that life left behind are called biomarkers, and that's one of the things this Perseverance rover is designed to help find. The rover will be cutting pieces of rock from the surface of Mars and collecting these samples. But one of the coolest things about this rover is that it's not just collecting specimens, it's actually going to help make sure these specimens eventually get back to Earth.
What the rover is going to do is actually collect samples of the surface materials on Mars and put them in tubes, and then we're going to be sending more missions to go get those tubes and bring them back to Earth and study them with much more powerful instruments here on Earth to hopefully give us a lot more information about that question. We've brought samples back from the moon. The Apollo astronauts brought pieces of the moon back so we could study them here on Earth. But this will be the very first time that we've been able to bring pieces of Mars back to Earth to study. Now, the interesting thing is that there actually are pieces of Mars on Earth that have come here as meteorites that got knocked off of Mars by big asteroids hitting the surface. But we have no idea where on the planet they came from. They're all what we call igneous rocks, so they were made in volcanoes, and they don't have any evidence in them that we can definitively say was evidence of life. So what we want to do is look at the kinds of rocks and sample the kinds of rocks that here on Earth typically contain evidence of life, like sedimentary kinds of rocks, or hydrothermal rocks that are altered by water, and look at those. So we really want to be able to select the kinds of rocks that we bring back. And we've never been able to do that before from Mars. It would be a really big deal if we found evidence for life in a place beyond Earth. This is one of the things that we're really interested in understanding, not just as scientists, but as people. Are we the only example of life that's out there? And finding another example would really be a big thing.
Why do we care so much about Mars?
So Mars is, in a lot of ways, it's very similar to Earth. So the basic makeup of the planet is the same kind of rocks. And so knowing that life started here on Earth and comparing Earth to Mars is a very natural kind of thing because the planets are very similar. It's also relatively close and fairly easy to get to. And I won't say that it's easy to land on it, but it's relatively easy to land on Mars, other than other places in the solar system. And so it's one of those areas that's familiar enough, but alien enough that it's really interesting from, an Earth perspective about things like what's the geology like and whether that geology can actually host life.
You said alien enough, and I just want to clarify, you mean different enough,
Different.
not alien, like there are aliens there that we know about.
Yeah, that's right. I mean strange.
Hi, my name is Max. I'm 7. I live in Chicago. When can we live on Mars?
When are humans going to live on Mars?
Well, we're still working on plans to try and get humans out there. And in fact, the Perseverance rover is going to have some technologies on it that will help us further that goal of eventually sending humans to Mars. So we're sending a couple of different technologies, one of which is helping us pinpoint the landing better. So that will be really interesting. The other one is that we're sending a weather station. So we'll be able to, keep track of what the temperature is and what the wind speed is and all that kind of stuff, which, one of the things people do in the morning first thing is they check the weather. What's the weather going to be today? So very important from a human standpoint. And then the final technology that we're sending to demonstrate for the very first time is being able to use materials at Mars that will help humans when they get to Mars. So the experiment will be to take carbon dioxide out of Mars's atmosphere, which is the primary gas in Mars's atmosphere is carbon dioxide, even though it's very thin atmosphere, and take that carbon dioxide and strip oxygen out of it. And so the idea is that if you can generate oxygen with this experiment, then you could think of building a bigger version of this experiment to provide oxygen for the humans when they get there, either as, air to breathe or, very importantly, as rocket fuel. So you need something to burn the rocket fuel, and oxygen is a great thing to use to burn rocket fuel. And so that would mean that if you sent humans there, they wouldn't necessarily have to bring absolutely everything with them. They could use what's at Mars to get back home.
In just a moment, we'll learn more about the atmosphere and landscape on Mars and why it's often referred to as the red planet. This is But Why, a podcast for curious kids. I'm Jane Lindholm, and today we're putting out a special episode in between our regularly scheduled ones because we got a chance to talk to Mitch Schulte, program scientist at NASA headquarters for the Mars 2020 mission and Perseverance robot. Mitch's job was to figure out which tools the rover should have on board when it lands on Mars this week. We have some kids who know a little bit or a lot about Mars who wanted to ask some specific questions about the planet. The first is from Julie, who's 5 and lives in Connecticut.
And my question is, why is Mars dry even though it's so far away from the sun?
Why is Mars dry even though it's so far from the sun?
What we think happened is that Mars used to have a thicker atmosphere and it had more water. But over time, Mars's atmosphere was sort of knocked away from it by the action of the particles streaming away from the sun. So there's this thing called solar wind, which are very high energy particles that come from the sun. And they, over time, have knocked Mars's atmosphere away from it. So Mars's atmosphere is very thin now, as I said, and part of the reason for that is because Mars is relatively small, so it just doesn't have enough gravity to hold all of the atmosphere there. And so the sun has been stripping away the atmosphere over time, and by doing that, it has sort of taken away Mars's blanket that kept it nice and warm. And that process, of course, has resulted in a lot of molecules, including a lot of the water, escaping into space.
So let me see if I can picture what that kind of is like. When we think about water evaporating here on Earth and it evaporates and goes up into the atmosphere, are you saying that then it sort of gets pulled out of the atmosphere in Mars and all that's left is the dry air because of the solar winds and because the atmosphere can't hold on to that moisture?
Yeah, exactly. And so when you break water apart, so when it goes into the atmosphere, it gets hit by radiation from the sun and breaks it into pieces. So the very light piece of that is the hydrogen. So water is 1 hydrogen atom and 2 oxygen atoms. If you break that apart, then it's easier for the hydrogen pieces to escape because they're very, very light. And so the heavier things tend to get left behind, but the light things escape. So that process of breaking the water apart and then losing part of it to space because of the sun is the result of Mars sort of drying out.
My name is Sila. I'm 8 years old. I live in Toronto, Ontario. My question is, what is Mars' atmosphere like?
So as we know from Julie, Mars is dry, but beyond being dry, what is the atmosphere on Mars like?
The atmosphere is very thin. So here on Earth, when you're standing outside, there is 1 atmosphere's worth of pressure pushing down on you. So that's what it feels like when you're standing outside. On Mars, that pressure is only 1/100th of what it is here on Earth. So it's not very much pressure at all. On Mars, the primary composition of the atmosphere is also very different than Earth's. So Mars's atmosphere is mostly made out of carbon dioxide. Here on Earth, we have only relatively small amounts of carbon dioxide in the atmosphere, and the atmosphere is mostly made of nitrogen and oxygen. On Mars, it's mostly carbon dioxide with tinier amounts of things like nitrogen and argon and other kinds of gases. So it's a very different composition. It's a very different pressure. And of course, because the atmosphere is so thin, then it's also very cold generally on Mars as well. And as I mentioned, the atmosphere here on Earth sort of acts like a blanket and keeps some of the heat in. On Mars, when the sun goes down, because there's not enough atmosphere to keep it warm, it gets really cold at night, as an example.
And describe what the landscape looks like from what we know so far of Mars. Pretend we're in the rover, we're in that little video eye of the rover. What would we be seeing?
A lot of things would be very familiar, and some things would seem kind of strange. So, for example, we see, that there are volcanoes, there are canyons, there are mesas, and all of those kinds of landforms that you see in the desert here on Earth, out in the southwestern part of the United States, for example. But Mars has the largest volcano in the solar system. So Olympus Mons is 3 times the size of Mount Everest. It has the largest canyon, and the canyon called Valles Marineris, if it were here on Earth, would stretch all the way from Los Angeles to New York. So just very big scale kinds of things. You wouldn't see any water on the surface, so you wouldn't see any lakes or rivers, but you would see dry riverbeds. also sort of like you might see in the desert sometimes. So like I mentioned before, things are familiar and yet kind of strange.
Hello, my name is Kinley, and I'm 6.5 years old, and I'm from Miramar, Florida, and my question is, why does Mars have 3 moons instead of 1? Thank you for answering my question.
Kinley asks, why does Mars have 3 moons instead of 1?
Well, Mars has 2 moons instead of 1. And so the difference is how each of the planets got their moons. So Earth's moon actually formed because very early, right after the Earth had started forming, it got hit by a big giant asteroid. And that collision actually resulted in having our moon. So the material that got thrown off of Earth combined with the material from the object that hit the Earth coalesced around the Earth to form the moon. On Mars, we don't know that same process actually happened, but the reason that Mars has its moons is still a little bit of a mystery, but one of the leading ideas about that is that a couple of asteroids from the asteroid belt, which is out past Mars, got a little bit too close to Mars, and Mars captured them gravitationally by gravity. So it sort of just brought them into its orbit. And so that's why Mars has those 2 moons.
And I wonder if what Kinley is also thinking about is that there's been some discussion that Mars may at one point have had a 3rd moon, right?
That's possible. Again, we don't really know. Because we see the 2 moons that are there. We do see evidence that there are meteorites on the surface of Mars. So the previous missions that we've sent to Mars, including the Spirit, Opportunity, and Curiosity rover, have all found pieces of asteroids or meteorites on the surface of Mars. So it's possible that there were more in orbit around Mars and they just crashed into the surface.
We have one more question that came from a few of you, but I forgot to ask Mitch Schulte while I was talking with him. So I'm going to try to answer it for you anyway.
My name is Simon. I live in Chicago, Illinois. I'm 4, and my question is, why is Mars red? Hi, my name is Betsy, and I'm 6 years old, and I live in Baltimore. And my question is, why is Mars red? Hi, my name is Alice. I'm 5 years old, and I live in Malaysia. My question is, why is Mars red?
That's a great question, Simon, Betsy, and Alice. Now, if you've ever looked up at the night sky and had someone point out Mars, you might have noticed that the planet looks kind of reddish. Mars looks red because there's a lot of iron in the Martian landscape. And when iron is exposed to air, it can oxidize or get rusty. And that rusty color is what you're seeing when you look at Mars. But it's not just the rocks and the landscape itself that looks kind of red. Remember how we talked about how dry Mars is? Well, that dry landscape can kick up a lot of dust, and that dust is rusty. So the atmosphere around Mars is filled with that rusty-colored dust, making the whole planet appear red to us here on Earth, because we're looking through the atmosphere, that dusty red atmosphere to the planet. When you actually look at some of the pictures that previous Mars rovers have sent back to Earth, you'll discover that the landscape on Mars isn't all red. There are lots of different colors to the desert landscape. Some of it looks kind of brown, some of it is sandy colored, some of it is pink or red, and some of the landscape even has a kind of green hue. But from here on Earth, Mars looks pretty red, so that's why we call it the red planet. We are bound to learn some new things about Mars from the rover Perseverance. You can find out all about it on the NASA webpage. We'll provide a link in the show notes and on our website, butwhykids.org. And if you're listening to this episode before Thursday, February 18th, 2021, you can even watch the rover land on Mars live. Well, almost live. Remember, it takes 11 minutes and 22 seconds for the signal to get all the way from Mars to back here on Earth. Things could change, of course, but it's supposed to land around 11:15 a.m. Pacific Coast time. That's 2:15 in the afternoon on the east coast of the U.S. and Canada, 7:15 in the evening in the UK, or Coordinated Universal Time. Are you going to watch? And do you think Perseverance will find any signs that there is, or maybe used to be, life on Mars? What do you think that life might have looked like? I guess we'll just have to wait and find out. In the meantime, thanks for listening to this special episode, and big thanks to NASA and Mitch Schulte for coming on the show. But Why is produced at Vermont Public Radio by Melody Bodette and me, Jane Lindholm. Our theme music is by Luke Reynolds, and we're distributed by PRX. We'll be back in less than 2 weeks now with an all-new episode. Until then, stay curious.